founded Microelectronics Incorporated, or also known as IMI, since 2008, and VIA Optronics GmbH, a subsidiary of IMI, as Principal Design Engineer. He graduated cum laude from the Central Philippine University, taking up Bachelor of Science in Electronics and Communication Engineering. He's also the 1998 ECE Board Exam Top 1. He's a candidate for Master of Engineering in Electronics Engineering in Salle University, Dasmarinas. To discuss sensors and sensor fusion, let us all welcome and give a round of applause to Engineer Trix Cajita.
Thank you.
Please take it away.
Okay, let's transfer ko lang. Share ko lang screen.
Okay.
Okay. Can you see my screen?
Sorry, sir.
Can you see my screen?
Yeah, we could.
Can you guys hear me loud and clear?
Yes, sir. Medyo choppy lang.
Okay.
Medyo
Medyo choppy.
actually medyo low yung quality. Mahis. Pero I think we're good naman. Okay naman.
Sinabi mo, pangit yung boses ko.
Hindi.
Okay. So let's start. So I'm going to discuss sensor fusion
Okay.
as applied to advanced driver assistance systems and autonomous vehicles. Okay. So our overview, first we'll cover driving automation, and then we'll try to explain what is sensor fusion, and then the common technologies used in sensor fusion, and then I'll give a bit more detailed explanation about the inner workings of automotive cameras, right? Because that's what I do for a living. Okay.
Yes, sir.
Sige. Kung may questions kayo, ano lang, just speak up. Okay, so driving automation. So why do we need driving automation? So yung driving rationale behind automation is to eliminate accidents due to driver errors and limitations. Usually drivers fail to see oncoming vehicles, or they fail to realize that the vehicle in front of them has stopped. So mga ganong klaseng errors. So yeah, we have to okay. So eliminate blind spots, and so also to provide early warning emergency assist systems, and also for driver monitoring in case, for example, your driver falls asleep. So we have your systems that focus on the drivers and make sure that the driver is awake and paying attention to the road ahead. Also to reduce intervention from the driver. So because most accidents are caused by drivers. So if we can reduce yung contribution ng drivers, then we might as well reduce yung number of accidents on the road. So for example, we have adaptive cruise controls and lane keeping, and also for emergency braking. So when the car in front stops, your car will automatically apply brakes to prevent a collision. And of course, yung ultimate goal is to eliminate the need for a driver. So yun ang pinaka-ideal. Wala nang driver, so lahat ng tao sa loob ng kotse are just passengers. So if you like driving, then this is bad news. Okay. So there are actually 6 6 levels of automation. Actually 5 lang because level 0 is basically walang automation. It's like the regular car. So this is defined in the standard SAE J3061. This is standard, like standard Society of Automotive Engineers so sa US ito. So level 0, walang automation, full manual control, lahat ng responsibility lies on the driver. And then you have level 1, there will be some form of driver assistance, usually single automated system. For example, adaptive cruise control. So you just turn it on while driving on the highway. Yung car na lang ang bahala in maintaining a safe distance to the car in front. It cannot steer. Hindi siya pwedeng mag-change lane. The driver still has to maintain yung control ng steering, but the speed is controlled by the vehicle. For level 2, there is a bit higher level automation. So multiple automated systems, like aside from control of the speed, acceleration, deceleration, there's also the control of steering. So it can stay within a specified lane. So an example of level 2 na automation is the Tesla autopilot. So I'm sure nakita niyo yan sa news. There are several, dami ng mga tao na actually use the autopilot to get from one point to another. Basically, iba natutulog pa. Although legally, hindi allowed yung driver to do that. They have to maintain, they have to pay attention on the road. So level 3, so sa ngayon wala pang officially released na production vehicle that meets level 3. There is a upcoming Audi vehicle na I think the feature is called the traffic jam pilot. It's level 3. It will be level 3 in Europe, but it's not yet considered level 3 in the US because of some regulatory requirements. So pag level 3, the driver can still take over, but it's optional. So halos lahat ng driving requirements, driving dynamics are controlled by the vehicle. Pagdating sa level 4, again, almost the same sila. But pag level 4, halos autonomous ito. But the limitation is that it's only allowed within certain conditions. Like, for example, there's a so-called geofencing. So to operate in level 4, there's only a specified area where a level 4 vehicle can operate autonomously. So pag lumampas ka doon, kailangan mag-take over ng driver. So usually this is enforced to limit yung speed. So usually mga less than, let's say, 40 kph or 60 kph, within that range only. So when you go out through the highway, so usually hindi na pwede. And then of course, level 5, the final level, is the full automation. No need for controls for human drivers. So basically, wala ng steering wheel, walang gas pedal, or everything. It's all basically a fully autonomous robot. Pwede yung sakyan. Any questions so far?
I guess none pa naman, sir. We can reserve, I think, those questions later sa Q&A portion po.
Sige, okay.
Thank you, sir.
Okay. So what is sensor fusion and why? So the concept of sensor fusion is to merge data from multiple sensors to form an accurate map of the environment around the vehicle. Multiple sensors, it's not just about having the same kind of sensors, but having different kinds of sensors. Basically, you have radar, you have LiDAR, you have cameras. So because each kind of sensor has its own strengths and weaknesses. So kailangan yung i-overlap yung data to form a map around the vehicle that will ensure na wala kang na-miss. So you have radar to detect the objects that are far away or even close, LiDAR for a more detailed map of the objects in front. And then, of course, you also have the camera to be able to read traffic signs, to be able to detect markings on the road. Yeah, and then of course there's also the case for redundancy and increased safety. If something fails, for example, if your LiDAR fails, dapat meron kang backup, which would be like yung radar. Okay. So ito, sensor fusion. So ito yung three common sensor technologies, and this is how they compare to each other. So for object detection, so radar and LiDAR are very, very strong in this application. Camera, it's also possible, they're capable. And for pedestrian detection, radar, medyo mahina ang radar in that case because pedestrians are usually hindi siya ganun ka-reflective in terms of radio waves. So LiDAR is good for that. Camera is also good for that. Weather conditions, ang camera naman, so like your human eye, it's easily affected by the weather. So malakas yung ulan, usually you have a very short range lang, makikita mo. And then, so lighting conditions as well. If your vehicle is pointing towards the sun, or at least the setting sun, for example, so medyo it can easily be defeated by the glare in camera. Same as well pag gabi. So if you have your oncoming vehicle has a naka-high beam, and so yung glare from that oncoming vehicle can easily blind the camera. But this will not affect radar and LiDAR. Dirt, yeah, if dirt will accumulate on the lens or on the windshield of the vehicle, then camera will also be affected. Radar, on the other hand, and LiDAR can penetrate and can pass through dirt. Thin layer of dirt, anyway. Like velocity, radar is also a strength for radar and LiDAR. Camera as well, it's a capability of the camera to detect velocity. For distance measurement, it's the strength of radar and also LiDAR. In terms of data density, so data density is the resolution data. So because radar medyo mahaba yung wavelength, its ability to resolve small objects is limited. Unlike LiDAR, which uses infrared light. So if you can imagine yung laser beam, it's a very narrow beam. So madaling ba kapag you can have a very high resolution map. And classification, there's also the strength of the camera. Packaging wise, radar is maliit na rin naman yung radar. The camera should be also good in packaging, although ang disadvantage ng camera is that it needs a clear line of sight. Unlike a radar, pwede mo siyang itago behind a bumper, for example, a composite bumper. So hindi kita yung radar, but it can still work. Okay. So let's discuss each technology. So radar, so I think everybody is familiar with radar. So it uses radio waves to detect objects, detect and measure the range of objects. So in terms of automotive radars, there are two categories. So there's the short range radar and then the long range radar. So yung short range radar, wow. So yung short range radar is normally have a wider field of view. So dito siya, 80 degrees, and then the long range radar is meant to scan up to 150 or 200 meters ahead of the vehicle. So, and then frequencies used are 24 gigahertz and 77 gigahertz. 24 gigahertz is being phased out right now. Everybody, almost all the manufacturers are moving towards 77 gigahertz because they have more room to play with at 77 gigahertz. Mas malaki yung allowed na frequency band of operation to 77 gigahertz. And also there are two types of radars, so continuous wave and pulsed radar. So pag continuous wave, it's meaning, continuous yung transmission ng radio waves. What they do is they modulate the radio waves to be able to measure yung time of flight from the transmitter to the object and then back to the receiver. Pulse radio waves, obviously you send out very short pulses of radio waves and then you wait until it returns. So yeah. And then so LiDAR, LiDAR is very similar to radar. The only difference is instead of radio waves, it uses light, or in this case, it's usually laser. It's usually yung ginagamit nila is IR laser with a wavelength from 950 nanometers to 1,500 nanometers. And then there are two types that are commonly in use: mechanical LiDAR, where you have an assembly with rotating mirrors and optics to scan the environment. This is actually old technology, yung mechanical LiDAR. And then it's quite being replaced right now by solid-state LiDAR. Under solid-state LiDARs, we have three types of LiDARs: the MEMS LiDAR, flash LiDAR, and optical phase array. Yung MEMS LiDAR is basically a miniaturized mechanical LiDAR. It's a microelectromechanical systems LiDAR. So we have mirrors, very small mirrors etched into silicon and then actuated by very, very small actuators, which are directly also etched into that silicon. So as you can imagine, it would be within probably in the microns yung sizes ng mga mirrors na yan. If you're familiar with the DLP technology ng TI, the one that's used for projectors. So it uses micro mirrors to project light, give a light source, and then it actuates yung mirrors to kung ano ang para ma-control niya kung anong i-reflect na ilaw. And that's basically how it's worked. Instead of the generic white light source, it uses a normal, an IR laser, which then is reflected to the target. And there's also the flash LiDAR. It's basically para siyang camera actually, where you project you flash a very short burst of light, scene, and then knowing yung time na you transmitted the burst of light, and then detecting yung delay when it comes back to the sensor. You can actually then measure yung range. So it's a camera with a built-in range detection. And then there's also the optical phase array. It's like the phase array antenna where you can change the direction of the beam by changing the phase of individual elements. So in this case, it's not a radio; it's using light. So this yung radar at saka LiDAR has very similar principles. With the only difference is yung wavelength ng signal na ginagamit nila. So radar obviously mas mahaba because it's using radio waves, and LiDAR is using light, infrared light. And between the 950 nanometers and 1,500 nanometer wave light, usually ang ginagamit then it's towards the longer wavelength. Because as you go further, it's like 1,500 nanometers, as you go longer, it becomes less sensitive to weather disturbances. Okay. And so let's move on to cameras. So there are two types of cameras, the analog cameras and the digital cameras. Analog cameras are no longer in use. Mga OEMs like BMW, yung mga car manufacturers. Usually, pag bibili ka ng mga rear view cameras sa market today, like sa Lazada or usually yung mga analog cameras yan. And pag analog cameras, they're limited to viewing applications, meaning from camera, dadaan ng maybe a little bit of processing, and then i-display the driver. So you're using it to replace, for example, a mirror, or the rear view camera. You're replacing the rear view mirror. So, yeah, viewing applications. If you're going to move into machine vision, so in which case it's usually digital cameras ang ginagamit. Sa ngayon, you might be surprised, digital cameras right now that are using cars are anywhere from 1 megapixel to 5 megapixels. And parating pa lang yung mga 8 megapixels and higher resolution cameras. So you'll be surprised kasi siguro nasanay tayo na for our cell phone cameras, meron mga 16, 32 megapixel cameras. And bakit ganun, no? Bakit 5 megapixel lang? Something like that. So yeah. The reason for that is usually pag lower resolution, mas malaki yung pixels. Pag mas malaki yung pixels, that means higher sensitivity, and higher sensitivity means better performance at night. So for vehicles, performance at night is very, very important. Kasi kung mahina yung performance ng camera mo at night, obviously it's basically useless. So if you're going to use that for machine vision, for detecting lanes, for detecting obstacles in front of the vehicle, then delikado kung ang performance ng camera mo is not up to par paggabi. Like for example, for 2 megapixel cameras, ang size ng pixels are 4 microns by 4 microns. And you can compare that with 32 megapixel camera, usually around 1 micron by 1 micron yung pixel. So that's roughly equal to 16 times yung size ng pixels. That means also 16 times more light ang pumapasok sa isang pixel compared to the 32 megapixel. So you have a 16-fold sensitivity. And yeah, so the newest sensors that are coming out of popular manufacturers like Sony and onsemi, usually mga around 8 megapixels na. There are already 15 megapixel sensors in the pipeline. So paliit din na rin yung pixels nila. So in order to compensate for this, they are switching from front side illuminated sensors to back side illuminated sensors. So what's that? Here's a simple overview ng DSI and FSI. So pag sinabing FSI, which is the more common type of sensors today, front side illuminated. So di ba sa silicon, when it's a wafer or a die, silicon die, you have a silicon at the substrate, and then you have junctions created by doping to form the various devices, integrated devices. So you have here, for example, the photodiode. And then on the top layer, you have the oxide layers and the metallization and the passivation. And then on top of that, the sensor manufacturer will overlay a color filter. So per pixel, usually iba't ibang kulay. May natawag silang color filter array. So RGB, red, green, green, usually a 2x2 2x2 na group of pixels. So may red, green, green, blue, or red, green, blue, IR, or red, clear, clear, and blue. So that's the color filter. And then on top of the color filter, there are micro lenses, which focus light on individual pixels. So if you imagine yung light, incident light impinging on the sensor, it will pass through the micro lens and then through the color filter, and then through the metallization, through the gaps between the metallization and to the photodiode. So as the pixels become smaller, yung gap, yung space between the metallization also becomes smaller. So konti na nga yung light na pumapasok. Mas lalo pa siyang nababawasan because of the metallization. So the solution of the manufacturers is to reverse the process. Binaliktad nila yung wafer, and then sa likod sila naglagay ng color filter and microlens. That way, the metallization is behind. So through the microlens here on the left, on the right, dadaan ng color filter, and then didiretso na ng photodiode. There will be no metal layer to block the light. So that's why pag maliit na talaga yung pixel size, they use BSI technology to reduce yung impact ng reduction in pixel size. Okay, so here's an actual automotive camera example. This is actually our product. So yung typical size niya ng body is around 1 by 1 by basically 1 inch cube. So it's relatively big compared to your cell phone camera. Normally yung interface niya is a coax, a single coax cable. And here, this is the internal block diagram. So we have here the image sensor on the left. And then we have a serializer. So the purpose of the serializer is to take data from the sensor and then transmit it to the ECU in serial mode. So basically, they send it in through a single channel. We have here also the power over coax filter, which splits the power and the data. So yung data pupunta ng serializer, tapos yung power pupunta ng power supply. Yung common nowadays, yung image sensor, yung output ng image sensor is the CSI2 interface, which is similar to your PCI interface. So you have one clock lane. A lane which consists of 2 lines, differential lines, and then 4 data lanes. So normal transmission rate ng data sa CSI2 is around between 800 megabits per second to 1.6 gigabits per second. There are four lanes of that. And then you have a serializer which further serializes the data. So yung transmission rate ng LVDS dito is around up to 8 gigabits per second. So ganun kabilis. Right. So actually, if you consider yung resolution, for example, yung camera mo is, for example, yung data coming out is around 8 gigabits per second. And if you're going to do fusion, sensor fusion, kahit na, for example, apat na cameras, you have 4 LiDARs and then 4 radars. Imagine the kind of processing power na required to merge the data and to come up with an accurate map. So that's also one limitation na kahit na that's why yung progression ng number of pixels ng cameras is not as fast as in commercial yung sa cell phones, because you also have the limitations sa processing power. So yung processing power which lies on the ECU. Okay. So and then I'd like to show you here's an example of a sensor from onsemi. So this is a 2.3 megapixel sensor. And it shows here the 1.27 inch format. So this format is actually indicates the size of the sensor. So it's a fraction. So the smaller the numerator, the bigger is the format. I think in the old cell phones, it's around mga 1/4 yung size ng sensor. And the newest sensor, I think yung Samsung na Galaxy S20, for example, is around 1/2. I'm not sure. And the biggest that was incorporated into a cell phone was the camera by Nokia. I think that's PureSense. I think that's almost 1 inch. Okay, so let's go through yung description niya. 1/2.7 inch CMOS digital image sensor. So there are actually two types of sensors, na CMOS and CCD. CCD is more expensive. It used to have a better performance, pero CMOS is catching up. And CMOS is more popular because it's more manufacturable and therefore cheaper. And then in here it says yung resolution niya is 1928 horizontal pixels by 1208 vertical pixels. So pwede na siya pang high def HD. It includes LED flicker mitigation. So what's LED flicker mitigation? It's kasi ngayon uso na yung LED lighting, and LEDs, when they're driving LEDs, they're not driving it continuously. Usually they drive it with PWM to control yung amplitude ng ilaw. So pag PWM, to a human eye, it's continuous lang yung ilaw ng LED. But to a camera, without LFM, makikita ng camera mo that the LED is actually blinking. So imagine if yung sensor mo, you're using it to read traffic lights, and then wala siyang LFM. So and yung traffic lights is using LED and it's blinking. What if it made the decision that the road is clear to proceed? Hindi niya nakita na red pala yung traffic light, because the time when it captured the image, so happened na nag-timing din na naka-off yung LED. So yun yung importance ng LFM. Kailangan there must be a way for the sensor to overcome yung driving method ng LEDs. Yeah, so it eliminates high-frequency LED flicker from traffic signs and vehicle LED lighting, and allow traffic sign reading algorithms to operate in all conditions. So as you can see here, it uses a 3-micron backside illuminated sensor. Yeah, and then there's HDR, so high dynamic range mode, and also ASIL-B. ASIL-B, what is ASIL-B? It's short for automotive safety integrity level. So there's this new standard called the ISO 26262, or the functional safety standard, where manufacturers are electronic manufacturers for automotive vehicles are required to ensure that when their product fails, it must fail in a safe way. Meaning, kung nag-fail yung, for example, nag-fail yung, ano mo, yung engine control, electronic engine control, if it fails, it must ensure na hindi unintended, for example, unintended acceleration. So dapat, if it fails, it's going to fail, it's going to stop. Or at least it's going to inform the driver na may problema yung sasakyan. So that's the goal of the functional safety standard. And lahat ngayon ng automotive suppliers, kung nagde-design ka ng electronics for cars, you have to consider this. Otherwise, if your product fails in the field and na-prove na hindi mo consider yung functional safety, you will be held liable for that accident. Right. Okay. Okay, I think that's it.
Okay.
Okay. Any questions?
Thank you, Sir Trix. That was interesting. Guys, do you have any questions? The virtual floor is now open for questions. Question ba tayo, guys? Sir, nag-start ka sa Ionics. Did you handle already camera-related electronic design products?
Nope. Yung sa Ionics, I was still working on multimedia and optical storage.
Mm-hmm.
So, di pa uso nun yung iPad.
Okay.
Yung mga media players pa lang.
I see. Ano yung ilan sa mga products nyo that time, sir, na dinidevelop nun? Sino usually yung customers nyo doon, sir?
Dati yung pinaka-frequent namin na customer na yung Philips. Yung uso pa yung optical drives, yung mga CD, DVD, and then if you guys remember, I don't know if you nabutan nyo yung
Ako nabuta ko yun, CD, DVD.
Yung war between Blu-ray and HD DVD.
Ah, yes! Mm-hmm.
Yeah. So, yeah, we were working with a chipset supplier that supported both para in case na one would pick up and the other will not, at least covered niya both areas.
So you supported both, ah?
Oo.
Ayos, ah. Namamangka sa dalawang ilog, ah.
Yeah. Panigurado.
And then when you came to IMI, ano yung first naging product handle niyo dun, sir? Yun na kaagad?
Hindi rin. Zigbee wireless modules.
Sorry?
Zigbee
communication.
Yeah, yung short range, low data rate na radio protocol.
I see. Nag-Zigbee.
Ako, hindi nyo naabutan yun eh.
I think some students are still using it for their thesis eh. Some use Zigbee pa sa data.
Yeah, hindi yata nag-pick up masyado yung Zigbee.
Parang hindi. Kasi Bluetooth. Yun.
Yeah.
No power.
It's intended normal usually for ano sana for mesh networking tapos sa mga
Talaga?
sensors, something like yung covered ngayon ng IoT. Yeah, so na-supplant siya ng IoT na mga standard.
I see. Ano bang mesh network tong nakita ko? Anyway. So, sa products, sa handle nyo ngayon, sir, na products, sinong usual mga customers nyo for automotive? So, may direct ba kayong customer, sir? Or, for example, Mitsubishi or car makers?
We're ano pa lang, we have customers, usually yung dati yung customers namin mga tier 1. Tier 1s are those that directly deal with OEM. Kasi the way the automotive market works is the OEMs, yung mga brands like BMW, Volkswagen, Ford, they prefer to deal with a preferred list of customers called the tier 1. So ito yung mga matagal na nilang ka-deal with. So like Bosch, for example, or Continental, these are tier 1 customers. So usually kami nagsusupply sa tier 1, tapos yung tier 1 nagsusupply sa OEM. And lately, we're starting to deal with directly with customers with OEM, like BMW. We're also dealing with upcoming electric vehicle suppliers, manufacturers.
All right. I see. Sir, may question dito from the students.
Yeah.
Sabi ni Darren, sir, baka pwede daw po paki-elaborate yung operation ng phased array LiDAR.
Familiar siya sa phased array na phased array radar.
LiDAR.
Actually, same sila ng principle, ng idea. You have kung sa radar, for example, you have multiple antennas, you have an array of antennas, and which transmit signals all at the same time.
Yeah.
In order to control the direction of the beam, what you're doing is you're going to change the phase of the signals that you're feeding each element of the array. So, if, for example, on the rightmost side of the array, you're moving the phase ahead, and then sa yung pinaka left side naman, you're delaying the phase. The tendency is to point the beam towards the left. Parang nadi-delay kasi siya. So yung wavefront mo is changing direction towards the left kasi nahuhuli yung left, nauuna yung right. Yan. In the LiDAR naman, ganun din. You have multiple sources of light. May array ka ng sources with way to delay yung phase ng ilaw. So that when you emit a pulse, hindi sabay-sabay. So one side will emit the pulse ahead of the other side. So the resultant yung phase ng or wavefront ng ilaw is skewed. So you're like changing the beam direction. So that's how it scans by changing yung phase ng individual array element. I think I saw it. Meron akong nakita na graphics kaya hindi ko nilagay sa presentation.
We have another question here, sir. Sabi ni Vince Daniel, Apple recently launched an iPad with LiDAR sensor for augmented reality and measuring environments. Do you think other mobile devices would also carry it in the future?
Possibly. Sunod-sunuran. If it picks up, siguro others will also follow suit.
Sorry,
sir. If the technology will, for example, customers will patronize yung technology na inintroduce ng Apple, yung the use of LiDAR. Then probably other manufacturers will also follow suit. But LiDAR, although possible naman kasi using yung cameras lang, di ba? Yung currently right now you have may AR na rin, and you're just using yung rear cameras ng cell phones, right? You can also use dual cameras to form a 3D map of the environment. So it's really just a matter of weighing kung is it worth introducing another device like a LiDAR inside the product, or are you just going to use yung existing sensors mo and then just rely on additional processing power to process yung data.
So here's another question, sir. Sabi niya, tanong ni Paul Anthony, meron po bang particular microcontrollers na ginagamit kayo sa application nyo ng for automotive for these sensors?
For cameras, meron mga low-level MCUs like PIC, like your PIC 16, yeah.
16 F84A
or
877?
Ulit, sorry.
PIC 16 F84A ba? Yung 877?
PIC 16 F8326 or mga ganun na family.
Okay.
So usually as small as possible. So limited lang din yung capability. So they're normally naka-ano lang siya sa, for example, initialization ng device or monitoring ng voltages, for example, using yung ADC ng microcontroller. So medyo limited lang yung capability. Although there are sensors that can be paired with the so-called image stream processors. These are ASICs na talagang designed to handle yung specific sensors. What they do is from the sensor, yung data mo, kung may, for example, you're using fisheye. So what the ISP can do is it can dewarp. Kasi pag fisheye, di ba, warp yan, may barrel na distortion.
Mm-hmm.
So with the help of the ISP, it can dewarp yung image, so parang it will appear na flat, or it can make it appear now you're looking to the left, the camera is looking to the left, when in fact you're just cropping and then dewarping yung image. So may mga ganong processors din, but these are ASICs, application specific. But the trend really is not to include ISPs or in the sensors, kasi ISP, so the more devices that you put inside the sensor, inside the camera, the more power is required. So pag more power, mas mainit, yung sensors yung image sensor is affected. Yung performance niya kasi may thermal noise. So preferably, all processing power is done sa ECU side. And then sa ECU side, there are, sa ngayon, yung isa sa mga cutting edge na mga technology yung magamit ng NVIDIA graphics processors like Savior or TX or Jetson. These are dedicated na rin sa pag-process ng images.
I see. So here's another question from Jean Carla. Sabi niya, aside from automotive applications, saan po pa kaya po pwedeng na-apply ang sensors, the ones that you use?
Sensor fusions, usually, ang pinaka-common would be, of course, yung kotse. And transportation lang usually common yan. So from cars to buses to trucks, there's no reason pa naman, for example, sa ibang transportation modes like vehicles, like airplanes or ships. So although, for example, if you're gonna be developing an autonomous robot in the future, I would imagine it would also use sensor fusion. Whether that robot is ambulatory or using yung wheels or tracks.
I see. Some career questions naman, sir. We're curious to know when you start after graduation, was working in semiconductor industry, electronic design. Was it your first choice, or bring us to your journey? How did you paano ba? How did you went from Iloilo to Cavite for the job?
Yeah, wala kasing masyadong industry sa Iloilo. So we went here looking for a job. And yung college ako yung OJT is in a radio station, and parang nakakaantok yung yung trabaho. You're going to just ensure na operational yung radio and all those things. So I wanted something that's more, I guess, challenging, that would require more thinking. I wanted to go into design. So originally I wanted to IC design, pero at the time I started, medyo limited lang yung opportunity. Yeah, and so ngayon marami ng IC design dito sa Pilipinas. But I guess I'm too old to switch. Nandun ako sa nakafocus na ako sa system level design. But it's fun. Design is fun.
I see. So you actively sought a job na in electronics design.
Yes.
I see. So nagpunta ka talaga ng Manila, ng Cavite to look for it?
Ano lang.
Or was it offered to you?
I looked for it.
Okay, I see. Nice. Sa LinkedIn profile nyo, you started with an IC layout job, right?
Yeah, it was for IC design. Pero I think at that time, tinamaan ng yung first .com
bubble.
bubble, yeah.
19, where was it? 2000, nga ba? 2001? .com bubble.
Something like that. Yeah, somewhere at that time.
Y2K. Ngayon. FYI, if I'm not mistaken, magka-batch kayo ni Dean, 1998. Tama ba, sir?
Oh, really?
Ang alam ko. ang alam ko. Yes. And si Sir Trix yung top 1. Nakwento niyo sa akin. Top 1 namin to
Ako mo, saying batch kami kumuha ng board.
If I'm not mistaken, yes, sir. Working student siya that time. Working student that time. So, if I'm not mistaken, if I remember it correctly, nakwento niya sa akin na top notch namin to. Top 1 namin to. Ayos ba? Incidentally, si Sir Norman Fuentes, if you know him from Maxim, director ng TSDA, is also batch 1998.
Oh.
I'm not sure kung kilala mo siya sa naman siya, test development siya.
Hindi ko kilala.
Wala, from analog guys ata ang kilala mo eh. Anyway, so yun. Guys, may question pa ba kayo? We're nearing the end of our webinar today. So it seems automotive mas preferred did I understand it right? Mas prefer ang low pixel or low resolution camera?
Not really. The reason na naglo-low pixel sila is because of the better performance. So the preference is better performance, of course. But if sensor manufacturers can come out with high megapixel sensors with equivalent performance, syempre, it will be considered with the limitation na kung ano lang yung kaya ng processing power ng existing CPUs.
I see. So dependent siya sa processors, processing power.
Yeah, you have to weigh everything together.
Mm-hmm. Dami din palang factor sa design na yan.
Yes.
Grabe. Lodi talaga kita eh.
Ayan ang pagpili ng girlfriend.
Sir! We're 95 here. Okay. Guys, any more questions? Kung na magtanong, malalaglag pa ako ng malalaglag. By the way, for your information, si Sir Trix, kung si Sir Trix ay, I think, kabatch ni Dean. Si Sir Trix, kabatch ko naman sa Masters. Woo! Defense na yan. Woo! Go, Sir Trix. Tapusin mo na.
Si Josh magde-defense para sa akin.
Ay, nako. Ayun. I guess wala na naman tayong other questions from the students. Well, thank you very much, Sir Trix, for your time. Alam ko medyo busy ka. Pinilit lang kita dito, pero you still accepted the challenge. Thank you very much for joining us and spending your time with us.
Okay.
Guys, pangkapan natin sa Sir Trix, if you can turn on your mics. Let's give a warm round of applause.
Thank you.
Lalim ng yung mag-gets yung iba. Anyway, so yun. Salamat. Thank you again so much, sir. I hope see you soon. After this ECQ, libre mo naman ako, tsaka hanap pa na ako ng girlfriend, okay?
Okay, thank you.
Wait lang pala, sir. Before we end, may ano daw tayo. Lagi ko nakakalimutan, may group picture with the students. So if you could kindly turn on your camera, group picture naman to.
Okay.
Alright. Wala pa akong panlibre ng kape,
Yeah.
Ka-lockdown pa eh. Pag ano na lang, after. Si Archie, malapit na rin, di ba? Oo
nga.
Swerte, online defense, walang pakain. Ano ba yan? Lugi. Mahal-mahal lang mga binayaran namin ni Agnes noon.
Dalawa lang kayo.
Hindi, tatlo kami ni Dims.
Okay.
Ayun. Siya, thesis 1. Ako, kami ni Agnes, thesis 2. Yun. Sakat sa bulsa. Alright. Guys, in the count of 3, please bring out your best smiles. Ready? 3, 2, 1, smile. Alright, so this is page 1. We are currently 96. We have 3 pages. So second page, muna kayo alis. Again, in the count of 3, bring out your best smile. 3, 2, 1, smile. Alright, last page. Okay, so again, in the count of 3. 3, 2, 1, smile. Okay, thank you very much for your time. Sir Trix, salamat. Yung libre ko, pagbalik na lang.
Thank you, Josh, sa libre.
Girlfriend ko hanap mo ko Ninong ko to ninong ko to. Thank you so much, sir. God bless you. Bye-bye.
Bye.
Thank you. Bye-bye.
Bye. Thank you.